Welcome students. In our last lecture, we studied about electrostatic potential energy. In this lecture, we will study about electrostatic potential. So now let us first understand what is potential energy and what is potential. Now students, consider a charge Q at this point. Let us consider this as x-axis, this as y-axis, and this as z-axis. If you will not consider this coordinate system, then also it's okay. Now if I select any point P at this point at distance r, then we know that at this point, due to this charge capital Q, there is an electric field E. Here there is an electric field. If you will select any other point also, here, anywhere around this charge Q, then also there is electric field present around it at each and every point. Now if I put another charge Q at this point, then what will happen? In this case we can say that a charge Q is placed in an electric field of charge capital Q, that means Q into E. So if we'll put a charge Q here, then in that case force will act on this charge. So it is clear that if a charge is then there will be force, and if there is no charge, then there is an electric field. Now once again consider this charge Q. So we know that there is an electric field around this charge in all the direction. Now in this electric field of charge capital Q, if I'll select any point P here, then we can say that there is an electric field due to this charge in this direction along the radial path. So at point P, as there is an electric field, and if I'll put a charge Q at this point, then now we can say that this charge Q has potential energy at point P, denoted by UP, that we have studied in our earlier topic. So if this charge Q is present here, then we can say that there is a potential energy. But if this charge Q is not present, then what is there at point P? Then we can say that at point P there is a potential due to this charge. So potential is there. We cannot say there is nothing here. There is a potential due to this charge. So we are going to study the potential at any point. So here this potential will be V at point P. So in an electric field at any point, potential is there. At any point you can consider this point, this point, this point. So in an electric field, different points have different potential, and so if I put any charge Q at this different points, then the potential energy related to this charge will also different at different points. Now let us start with the mathematical points or steps related to this topic. we already know about electrostatic potential energy at any point P. This potential energy is due to the work done to bring a charged particle from infinity to a given point P. So when we bring this charged particle from infinity to this point P, we need to do some work, and that work done is nothing but the potential energy of the particle at point P. So this you have already studied. Now, what is work? Work is F dot D. It is a dot product of force and displacement. So here also the work is done with the help of this electric force Fe and the displacement, and there is a dot product here. So we have simply kept the formula of the work, that is F dot D. Why there is a negative sign? This we know that it is because the electric field or the electric force and displacement, they are in opposite direction. Next step, simply we have kept the formula of force. We know that electric force F is nothing but it is Q into E. We have studied this in chapter number 1, that if we put a charged particle in an electric field, then force will act on this charged particle. So we have simply kept this Q into E in place of this Fe. In that previous step, this charge Q is constant, and so it is taken out. Why this electric field is not taken out? It is because at different distance or different points, electric field is different, and so electric field is not constant in this case. The constant is charge, and so it is taken out. Let us give this equation number 1. We know that this infinity and this point P, they are the limits, because the charge particle is brought from infinity to this point P. So considering this charge Q as a test charge, and its value is 1 unit, means we can say that its value is 1 coulomb. So if we consider this as a test charge whose value is Q is equal to 1, then we get the potential at point P. When charge Q is there, then it is potential energy. But if Q is not there, then it is a potential. Rest of the things as it is. Once again, from this equation number 1, if we bring this charge Q from right side to left side, then we get this step, that UP upon Q is equal to this. But what is this? It is same as this, and that is nothing but is potential. So we can say that one more formula for potential at point P is UP upon Q. Simply we can combine equation number 2 and 3 to get this final result, that Vp is equal to UP upon Q is equal to minus integration from infinity to given point E dot dr. Once again, remember this Vp is a potential at point P. UP is the potential energy at point P. Now we can easily define electric potential at any point. Now here the only difference between the definition of electric potential energy and electric potential is that the word unit positive charge. In the definition of electrostatic potential energy, the word unit is not there. But here the charge Q is taken is equal to 1 unit, and so in the definition of electrostatic potential the word unit positive charge is used. The rest of the thing is as it is. And so here the definition says that the work required to be done against the electric field. We know that electric field was in this direction and we need to bring that unit charge from infinity towards this direction. So against the electric field. In bringing a unit positive charge from infinite distance to a given point in the electric field is called the electrostatic potential at that point. Now let us see some important points. Unit of electrostatic potential. Symbol is V, and from the formula onwards we can say that V is equal to U upon Q. This is the formula for electrostatic potential. And so energy, potential energy is in joule and this charge is in coulomb. So unit of electrostatic potential is joule per coulomb. Dimension in terms of ampere or in terms of charge. Now as I said, you can easily obtain the unit or the dimension if you know the formula. Now how this dimension is obtained in terms of ampere as well as in terms of charge, that is your self work. I hope you will be able to do this. If you are not able to do this, then you can definitely ask me. Next point, the things which were earlier explained for the electrostatic potential energy, the same thing is here for electrostatic potential. It is that the individual potentials at any point. Suppose this is the potential at point P, that is Vp, potential at point R is Vr. So that individual potentials are not having that much important or a significance, but the difference in the potential, that is Vp minus Vr, or you can say Vr minus Vp also. In short, the difference in the potentials is very important. And if we take here difference, so here also in the formula also there is a potential energy difference upon charge Q. So remember the individual potentials at points Vp and Vr. Here there is a correction. It should be Vr. So individual potentials are not having any significance, but the difference in the potential is having significance or the importance. Third point says that when we find electric potential, in an electric field, then that electric field can be due to the system of charged particles. Here, in above derivation of the electric potential, we simply considered a charge capital Q, and we have selected a point P, and we obtained the potential at this point, and we have considered the electric field only due to this charge Q. But here this point says that the electric field E can be due to many charged particles. Suppose if there is a charged particle Q1, there is another charge Q2, there is another charge Q3, and so on. So if we want to find the potential at this point P, then here at this point the electric field E is due to all these charged particles. So here at point P we need to calculate the net electric field or the resultant electric field due to this system of charged particles. So this is all about electric potential. I hope you understood this topic. If any doubt or difficulty is there, you are most welcome.